Let's solve this rational inequality. As soon as I see that greater than sign, I know this is one of those problems where I'm going to graph some critical values on a number line and do some test values to see where the solutions are. Now, how do we find the critical values that go on the number line? For rational functions, functions that have these fractions in them, we find the critical values from two sources. The first source is any excluded values that there are. For example, x cannot equal 0 because you can't divide by 0. X cannot equal 0. So that's going to be one of my critical values. Also, you can get more critical values from the related equation 2 over x plus 3 equals 29 over x. If we solve this equation, that will give us another critical value that will break up the number line. The way I like to solve this type of equation is to make all the denominators the same. So all I need to do is put an x under the 3 to make all the denominators are the same. That's only valid if I also multiply the 3 by x. Because, I could cancel these out and get right back to where I started from. So I haven't really changed anything. Once the denominators are the same, you can cancel them out and make a new equation based on the numerators. So 2 plus 3x will equal 29. If I subtract 2 from both sides, then I get 3x is equal to 27. When I divide both sides by 3, I get x is equal to 9. So this is my other critical value. So x equals 9. Now, excluded values are always graphed as open circles, which makes sense because an open circle indicates that this particular value is not to be included in the solution. And of course, an excluded value, an illegal value, is not to be included in as part of the solution set. Now, the critical values that come from solving this equation, sometimes they will be open circles and sometimes they will be closed circles, depending on whether we have greater than or equal to. Alright, that will be a closed circle, as opposed to simply greater than, which will be an open circle. We put an equal sign into the problem. So this value of 9 that we found is the value that causes the left side to be equal to the right side. So if we want to include values where they're equal, then of course we'll make this a closed circle. If we don't want to include values that are equal, but we just want values where the left side is greater than, then we will leave this an open circle. And that's the situation here. We don't want the values that make the function equal on both sides. We want just the values that make the function greater on the left side. So open circle. So of course this is 9 and this is 0. Now we have the number line divided into 3 zones, and we're going to need to choose some test values. Something to the left of 0. So for example, f of -1 would be fine. Something between 0 and 9. So I'm going to say f of 5. And then something bigger than 9. So I could say f of 10. Alright, so you don't have to pick the exact same values I did. I could have done -2 or -3, or over here this could have been 12 or 15. Now let's evaluate the function and see what's going on. See if we get a true statement. Here, this is sort of a special case. Normally we have a number over here, so I just put the left side of the function in my calculator or whatever I'm going to do. But in this case we have a variable on the left side and we have a variable on the right side. So I want to teach you a special technique to help you handle functions where you have variables on both sides. Now the bottom line is I am going to simply subtract this fraction from both sides of the equation. So I'm going to take this 29 over x and I'm going to subtract it. So it's going to wind up over on the other side with a minus. So the new version of the inequality would look like this. So I would have 2 over x plus 3 minus 29 over x is greater than 0. Okay, so anytime you have a variable on both sides of the inequality, go ahead and get 0 on one side by subtracting away this expression. So now we have just a number to compare to, so that's going to be easier than trying to evaluate both sides separately and compare them. So I'm definitely going to use my calculator to help me evaluate the function. So I'm going to put in this left side in the calculator. So I've got 2 over x plus 3 minus 29 over x. So plus 3 minus 29 over x. Okay, so there is the function which we want to compare to 0. Make sure you are in Ask X mode. Okay, so the three values I want to evaluate at are -1, 5, and 10. Oh, look, -1's already there. So -1, 5, and 10. Okay, so these are the values I get. Alright, so let's see. So I have 30, -12 over 5, and 3/10. Alright, that's the value of the function at each one of these numbers. Now the question is, are they greater than 0? Because this is what we put into the calculator. This is what we are investigating. Is this greater than 0? So is 30 greater than 0? Well, yes, it is. It's positive. Is -12/5 greater than 0? No, that's a negative number. Is 3/10 greater than 0? Yes, again, because that is a positive number. So the yeses tell us where the solutions are going to be. So -1 turned out to be a solution to the inequality. So that means every value in this zone will be a solution. 5 was not a solution, so none of these values would be solutions. 10 was a solution, which means every value in this zone is a solution. So this is now a graph of my solution set. In interval notation, that would be -infinity to 0, round parenthesis, because this is an open circle, not included, and a round parenthesis means 0 is not included. Union, and this one goes from 9 to positive infinity. Again, round, because of the open circle. So that is the solution. So now we just have to find it. Let's see, -infinity to 0, and then 9 to infinity. Alright, notice the only difference between C and B, really all of these, A, B, and C, the only difference is the round versus square brackets. Okay, so the answer is going to be C, because it has the right numbers and the round parentheses that we needed.